Hi guys, I hope you're good since the last video. I'm exploring AI and finding the way to have something to listen to while running or working to keep feeding our brains with knowledge. So sometimes you get it when being explained in different ways. That's why I have hired 2 characters from Google AI engines, and they will be watching my videos and talking about the knowledge that I have shared with you, but explained in another way, with one character being the one who needs to understand stuff, and the other the one explaining the concepts using analogies. Please like and subscribe, and I leave you with Mira and Brett.
All right, so today we're diving deep into Rust boxes.
Oh, fun.
Yeah, you've been looking to memory management, right? Send over some notes and even a whole YouTube tutorial.
Yeah, that tutorial was great. It has such a cool approach to learning.
Right, it was like a 5-step process, I think.
Yeah, 5 steps. Devour videos, then brainstorm uses, then code, make mistakes, then teach what you've learned to somebody else.
Oh, wow, that's a...
And finally, engage with the community.
Yeah, I liked that they even talked about ChatGPT as part of the process.
Right, it's all about using what's out there to really get it.
Yeah, it's not like cheating or something.
Exactly.
It's just part of how we learn these days. So let's dive in. When we talk about Rust boxes, what are the big things we got to unpack for the listener? What are those core ideas?
Well, let's start with the basics. What exactly is a Rust box?
Okay, yeah, great place to start.
A Rust box is essentially a smart pointer that allocates data on the heap instead of the stack.
Okay, so right away we're talking about the heap. Can you remind everybody real quick, what's the difference between the stack and the heap?
Yeah, so think of the stack like your short-term memory
Okay.
and the heap like long-term storage. The heap gives you a lot more flexibility when it comes to managing memory.
Okay, so why do we care about this heap allocation then? What does that let us do, especially in Rust?
Well, imagine you have like a massive data set or a really like intricate data structure. Trying to cram all that onto the stack would be, well, like trying to stuff a huge suitcase into a tiny backpack. It just wouldn't work. Boxes let you put all that data on the heap, which has way more space.
Makes sense. So like a warehouse versus a, what do you say, a backpack?
Yeah, exactly.
Okay, so more space. But why not just always use the heap then?
Well, that's where things get interesting. The stack is way faster to access. Think of it like grabbing something out of your desk drawer versus driving all the way to a warehouse. So Rust prioritizes using the stack because it's efficient, but for bigger or more dynamic data, that's where boxes and the heap become essential.
So you got to use the right tool for the right job. Okay, I'm following you. Now, the tutorial you sent also mentioned something called trait objects,
Yes.
and that they're often used with boxes. What's the deal with those?
Trait objects, they're kind of like surprise boxes, I guess you could say.
Oh, that's fun.
They let you work with data where you don't know the actual type until the program is already running.
Okay.
Like, say you're building a program that has to process different kinds of files.
Like images, videos, things like that?
Right, exactly. You might not know what specific file type you're dealing with until the user uploads something, but you still need a way to store and process all that data.
Right.
That's where trait objects and their trusty sidekick boxes come in.
Oh, so the box is like the shipping container for whatever surprise is inside. And we don't know what that surprise is until it shows up.
Pretty much. The box lets you manage the memory for that data on the heap, even if you're dealing with a mystery type until runtime.
That makes sense. Okay, so I think I'm getting this. But now there's this other thing they keep mentioning, downcasting. And that's where my brain starts to go a little fuzzy. Can we break that down?
Downcasting. Well, remember those surprise boxes we were just talking about?
Yeah, or trait objects.
Sometimes you really need to know exactly what's in that box before you can do anything useful with it.
Makes sense.
Downcasting is like unwrapping the mystery, revealing the true identity of the data inside.
So if our trait object is that mystery box, downcasting is like ripping off the wrapping paper so we can finally see what we got.
Exactly. It's like, okay, I've got something here, but what is it? A book? A toy? Who knows? Downcasting lets you figure that out.
All right, so I think I'm starting to get the big picture here. We got boxes as our containers, trait objects as the mystery items, and downcasting as our way of figuring out what's hidden inside. But then there's this other thing, and this is what really caught my eye. Using enums as box types. What's going on there? Is that like another way to handle those mystery items?
It is. And I'd say often a more elegant and efficient way. Instead of having, this generic box that could be hiding anything, you define an enum that says, okay, these are the specific possibilities we might be dealing with.
So it's like building a custom box, but it has compartments for each type of thing we might want to store.
Perfect analogy. It takes away the guesswork and can really streamline your code. We'll get into the specifics with some examples coming up, but first, I want to look at that Castella example they give. It shows how boxes work with structs.
Oh, yeah. Let's see how this all works in action.
All right, so this Castella example, it shows us how to make boxes holding different types, and then use that downcasting to actually work with them.
Yeah. Okay, so they start by creating this vector called VBox Castella.
Yep.
I'm guessing that's where they're going to store all these different data types as boxes out there on the heap.
Exactly. And they kind of take a roundabout way to get there. They start with an array, then they turn it into a vector with that vec from thing.
Oh, yeah, I noticed that. Why not just make the vector straight away? Seems like an extra step,
It's subtle but important. Rust wants to know the exact type of everything, right?
Right.
So to get a vector that can hold a mix of types, they use the array as like a temporary spot.
Okay.
More flexible with mixed types.
Yeah.
Then mec from turns that array into a vector of boxed-in, which is like the wildcard can hold anything.
So they're using the array as a kind of like a staging area to get all the different types into a shape the vector can handle.
Exactly. Got to work within Rust's rules, right?
Right. Okay, so then they've got this function, box simple downcasting.
Yeah, that's where the action starts.
Looks like they're going through the vector and using downcast drift to like peek inside each box and see what's what.
Like, hey, box, what you hiding? You an integer, a string. Spill the beans.
Yeah. And depending on what they find, they do different things.
Right. They've got those if-let statements for each possibility.
Mm-hmm. One thing that's throwing me off a little, they're using some in each of those blocks. Seems a little out of place.
Good eye. Remember, downcasting, it's not always a sure thing.
Oh, right.
You might try to downcast to a string, but it turns out it's an integer. So downcast drift gives you an option. Could be sum with the value, could be none, empty.
So some is their way of checking if they actually got something before trying to use it.
Safety check. Don't want to crash the whole program if the downcast didn't work, right?
Makes sense. So this simple downcasting is actually a little more tricky than it looks at first.
Yeah, but nuanced.
Okay, what about this next example? Box downcasting Shinyogi Kasi. They're doing even more here, right?
Yeah, building on what we just saw, still a vector of boxes, but now they're passing a mutable reference to it into the function.
Mutable meaning they can change what's inside, right?
And Gorgo adds another layer of power to it. They use push to add more boxes, showing how you can make that data structure grow on the fly.
Interesting. And they're not just going through the vector one by one this time.
Yep.
They're picking out specific elements using those indices.
Yeah.
Why do that?
Sometimes got to be precise, right? Work with things in a certain order.
Right.
This shows how you can reach right in and modify elements directly by their number in the vector.
Okay, so it's about having that control over how things are arranged.
Exactly.
I'm also noticing they're using those match expressions here. Is that just a fancy way of doing those if let things?
You could say that. Match is like super powerful for handling lots of possibilities.
Okay.
But keeps the code nice and tidy.
Yeah, and they're even nesting them. Getting pretty complex.
It's true. But there's a beauty to it, too. Once you see how it all clicks together, very logical.
Yeah, starting to see the power of Rust here.
It's a flexible language.
I bet our listeners' brains are working overtime right now. Maybe they need a minute to play with the code themselves and see how this all works.
Probably a good idea. Take a breather before we get to that last example where the magic of enums as box types really shines through.
All right, ready for the grand finale. Enums as box types. I got to say, when I saw this in the tutorial, light bulb moment.
It is kind of cool, right? Enums, they make things so tidy when you're working with boxes.
Yeah. No more messing around with all that downcasting.
Right. You're not guessing about the type when the program's running. You lay it all out with the enum from the start.
Right. So, okay, they've got this function, custom and unbox check.
Yep.
And it takes just one argument, custom box, which is a boxed in. So it can handle any kind of box they throw at it, but they're going to give it a box with an enum inside.
Right on. And that enum's called manga kisazone. Remember how they defined it before? Got variants for attendance, temperature, even a comment section, each one holding a different type of data.
Oh yeah, so it's like one container, but with little compartments inside, all neatly labeled.
Yeah, I like that. And then inside the function, they use that let thing and downcast drift to see if the box has one of those manga kisazone enums.
Mm-hmm.
But here's the difference. They're not downcasting to like a string or an int. It's the enum itself they're after.
So it's like asking the box, hey, are you one of those fancy manga kisazone boxes?
Exactly. And if it is, they use a match to handle each possibility within the enum.
Okay.
Really sleek way to process the data, follows the structure beautifully.
I see they're using those placeholders in the println, too. Seems like a good habit to get into with enums.
Yeah, keeps the code clean. Don't have to hard code values. Those placeholders grab the data right from the enum variant.
Makes sense. Then they create that SHISA level 7 variable.
Yep.
That's a boxed-in eni with a manga kisazone inside, and this time it's got a string.
Uh-huh. Even though they're putting the enum right into the box, still got to cast it as a boxed-in any because that's what the function expects.
Got to put on that generic label so any function can handle it, right?
Right. And then when they run the code, boom, it works. Finds that manga kisazone and prints out the right message based on what's inside.
Pretty cool.
It is. Great example of how enums can really make working with boxes and Rust so much smoother.
Wow, I feel like we covered a lot today. Lots of info for the listener to digest. What are the big takeaways here?
Well, Rust boxes. Those are your best friend when you need to manage data on the heap.
Got it.
Give you the power to handle those big data sets, the complex stuff, and all those trait object mysteries we talked about.
Yeah, and while downcasting helps us solve those mysteries, sometimes using enums as box types just makes everything cleaner and faster, right?
Absolutely. Think of it as making specialized containers for your data.
Love that analogy.
Yeah.
So, as our listener continues their Rust journey, what should they be thinking about?
Think about how all this can help you write more solid, efficient code. Don't be afraid to play around. See how boxes and enums can team up to solve those real-world programming puzzles.
And even if it feels tough at first, just take it step by step.
That's it.
The more you practice, the easier it'll get.
Keep diving deep, keep finding those aha moments, and keep pushing yourself with Rust. It's a rewarding language to learn.
Great advice. All right, until next time, happy coding, everyone.
Thank you, Mira. Thank you, Brett, for presenting my video in this way. That was amazing. You used my words and video examples perfectly. I might ask to work with you again, as I'm very busy at the moment. Hope that you liked the video format, guys. Please like and subscribe, and see you next time.